So let's begin with this video about the definition of limits. What is a limit? This will be the basic definition for what is a limit, because this is an important concept that you have to study again and again this first partial. So we have here the informal definition of limit. We have that if f of x, that is a function, remember this thing is a function, becomes arbitrarily close to a unique number, that means that you can approach any number that you want. That number L, this is for y, as x, this is important thing, as x approaches some number called c, this will be any number that I will assign to x. So when x approaches any number that you want, from either side, we have two sides, right side and left side. So we have to review it from either side, from the right, that is a plus side, and left side, that is this negative sign here. If we have a coincidence between these two sides, then we said that the limit of f of x, this thing, L, as x approaches c, remember this is any number, is L, so that is a value, it's the value of L, this is another value, and we write the following thing. The limit when x approaches c of f of x is equal to L. The meaning of this, and easiest way to understand this, is what is happening with y. The limit is also y. The limit is L is the value for y, is the value for y, or f of x, remember that is the same thing, when x approaches some number. When x approaches some number called c. So that is the easiest way to understand this definition. Remember, when we are talking about a limit, we are talking about the value of y. So if we want to exemplify this using numbers, we have the following thing. We will set that the limit when x approaches c of f of x will be equal to some number called L, okay? If and only if from the left side, the limit when x approaches c from the left side of the function is L, and the limit when x approaches that same number from the right, it's also L. So that will happen from the same thing will happen from the left and from the right in order to make this limit or in order to identify that this limit exists. A numerical example will be the following one. Imagine that we make an analysis of a function. So if we have that the limit when x approaches, let's say, 3 from the left of a function is equal to 5. Let's imagine that from the left side, the value for y is equal to 5. And from the right side, the limit when x approaches 3 from the right side of the same f of x is equal to the same number 5. When we have this coincidence between numbers 5 and 5, then we will set that the limit when x approaches 3, the general 3, so look at this one, we don't have anything here. These signs are only used to identify if we are talking about the left side or about the right side. The limit of the general limit of the function, the limit of when x approaches 3 of f of x will be equal to 5. So we have a general limit. This thing is called general limit. General limit, and these ones here, these things here are called partial or lateral limits. Partial or lateral limits. So in order to have a general limit, from the both sides the number has to be the same thing. The same thing will happen with y when x approaches some number. But if the number is not the same one, then the general limit will not exist. So the meaning of that is that, imagine that we have, let's say, the limit when x approaches 1/2 from the left of f of x is equal to -3. And the limit when x approaches the same number when x approaches the same number 1/2 from the right, instead of being -3 is, let's say, 7. From the left side we have a value of -3 for the limit. From the right side we have a value of 7. But the general limit, the thing is that the general limit, the limit when x approaches 1/2, does not exist at all, because the lateral limits are not the same ones, and we will say that this limit does not exist.